So for the upcoming homework, you're gonna plot a QQ plot. Um, the way is we will use the Minitab 19. That is the software endorsed by Stern. And basically, you just go to Google and you search Stern apps, and you just choose the SSO Stern apps and you choose login. Here you see Minitab 19. Like there's a whole bunch of other statistical software. Like you have Stata, you have R, you have RStudio, something which could be very useful. But like those kind of software also requires some coding experience. So basically, Minitab 19, I guess, is a good one if you don't have any coding experience and you want to find another software which is statistically more powerful than Excel. Um, but here, like you're not allowed to download that software. Actually, that software is kind of expensive. I guess it's like $99 per month if you really want to download it. And for student discount price, it's still expensive, like cost I don't know, a couple hundreds every year. Um, but here, by go to Stern Up, you have a chance to get the Minitab environment, which means you cannot download the app, but you can use that in a like short period of time. Um, and again, you have to save your data very frequently because if you do nothing, like some inactive, like if it is inactive for 10 minutes something, um, the environment just gone. It said your session is expired, and all of your data, if you don't have a chance to save your data, are gone. So, but this is a very helpful way to do some statistical tasks. Um, I don't know. So basically, just whenever you run some regression or you simulate some tasks, you have to save your data all the time. And for the homework, basically, all you need to do is you download or take some screenshot of pictures um, of some result runs, and you can paste that in a Word or like make it a PDF something, and you just hand in your homework. But basically, you need like 2 or 3 minutes to initiate this environment. Um, you don't have to use Minitab 19 all the time, but in this semester, I guess there's 2 or 3 homeworks related to some data analysis, and you cannot do it by hand because that's so many calculations. I don't know what's going on here, but it's just my session taking longer time than expected. Never happened before, but I I cannot download it. So here it goes. Um, and the format is very similar to that of Excel. But Midterm 19 has like more powerful function in terms of statistical analysis. Um, okay, so basically you go to calculate, I think calculate random data, and here you have exponential. You want to, like here, you just utilize this software to help you simulate 10,000 random data that follows an exponential distribution, right? The computer has its way of simulating data. That's great. Parameter equals 1, I guess that is the scale here. That means um, the average of those exponential distribution is 1. That is the mean, right? You can have some view of those kind of data. You find a lot of them are below 1, right? Some of them, 2.77, 2.5, you know, larger than 1. Then you go to graph and histogram. Actually, you don't have to do any adjustment in like scale labels. Um, I think the default version is enough. And you can choose this output only. Find the histogram. And, can I make it bigger? Oh, I don't know. So basically, this histogram is very exponential by the first glance, right? Although the mean is 1, like the mean is kind of between here 0 and 1.6, like somewhere there. But you can see like the majority of the number is smaller than 1 and but greater than 0. And some other numbers they are significantly larger than 1. Like we can still find, the value equals, I don't know, maybe 5, more than 5 something, right? So that is very exponential. Then you're gonna do a QQ plot, and you should expect the QQ plots will not follow a straight line because when you do a QQ plot of an exponential distribution under a standard normal distribution, it cannot fit. The QQ plot is a powerful tool to help you determine if two samples are from a same distribution. Um, by the way, the QQ plot um, QQ plot is also called probability plot. Right, so basically here, I want to check if my generated distribution is is the same as a standard normal distribution. I think that's the question asked against the standard normal distribution. Basically, when you get a set of unfamiliar data, you want to know what distribution it is. First, you're gonna plot a histogram. That is a that is the first thing you do. And here, visually, it seems like exponential, but maybe it's normal. Actually, not quite possible. But basically, first you do a histogram, and second you plot that in a QQ plot. And here I want to check if my distribution is a normal distribution. Then I plot it against a normal distribution. and I get a QQ plot, which is we expect those kind of things happening. It cannot be a perfect straight line because exponential distribution cannot be a normal distribution. Um, the red line is what a normal distribution looks like. Um, you see, when our mean is 1, we still our mean equals 1, right? Our mean, like is somewhere between here 0 and 2.5 is our mean. And the standard normal distribution have a standard deviation of 1. So basically, you see 2.5 is about 3.5 standard deviation away from our mean. And if if I have a normal distribution, I should have like um, 0.01%, around 0.01% of my data is 3.5 standard deviation away from the mean, which makes sense because a normal distribution is like there's very little observation of data set that is 2 standard deviation from the mean. Here I'm talking about 3.5 standard deviation about the mean because my mean is 1 and here some extreme value goes to negative 2.5, right? 3.5 standard deviation from the mean should be very, very little data. That is that is how you interpret this red line. However, our actual distribution is the blue line here. We find no data below 0. That's because we have exponential distribution. Um, and actually, if you find maybe one is between 0 and 2.5, right? And if you go up, go up, go up, and to see the the vertical axis, we find maybe around 80% of my data is below 1 and only 20% of the data is above 1. But you find some extremes. You even find this dot, the upper right dot. This dot, maybe I find a value of 11 or something. You have more extreme values, but in a normal distribution, you don't have those kind of outliers. In fact, you don't find too many observations which are 2 standard deviations from the mean. This is what you're gonna do, and in homework you're gonna simulate another 3, I guess, exponential, and you choose the mean. Other than 1, you choose I think 2, 2, 5, and 10, and you generate 10,000 data set, and then you put them in one column. I guess uh, I can only copy paste those data set in order to put them in one column and then do a QQ plot again. Basically, you find similar answers. Uh, However, if I want to check if my simulated data is an exponential distribution, what can I do is I plot a QQ plot, probability plot, single, and here the distribution, instead of choosing against the normal distribution, I choose exponential distribution with mean equals 1. And you see here my QQ plot is kind of a straight line, which indicates my um, unfamiliar distribution. Although in this case, I know my distribution is exponential because I generated it. But in reality, I get a set of unfamiliar distribution, and then I plot that distribution against exponential distribution in a QQ plot, and it shows a line, a straight line. Um, I know my unfamiliar data is aligned with exponential distribution. Here it said the p-value is greater than 0.25. I'm not so that means the probability of my distribution being an exponential distribution has a probability of more than 25%, which is not bad. But if you look at the first set of data, first QQ plot, the p-value is less than that small number. That means my distribution being a standard normal distribution have a very, very low probability. And in statistics, we usually set the cutoff of 5%, which means if my p-value is less than 5%, I will reject my null hypothesis that my distribution is actually a standard normal distribution. So I reject the null hypothesis. But in this case, I can't reject my null hypothesis because the p is greater than 25%, which means I have relatively huge chance that my distribution is an exponential distribution. I think the question two is exactly what I just said. Like in reality, you get a set of unfamiliar data. You don't know what distribution it fills in, right? First, you plot a histogram. In this case, I don't want to do that because like I have to copy paste all those data. I don't want to do that. But I assume the stock returns should be same like a normal distribution, meaning the returns should be like maybe the mean is around zero, right? The return sometimes I get 10, 5%, 5% fluctuation in a day, but it's very rare. In most cases, the daily returns is around zero, so the histogram should be centered at zero. And sometimes I gain money, sometimes I lose money, but it looks like a normal distribution in terms it's centered in the middle and it's symmetric, right? But is that really a normal distribution, right? It's hard to see from the histogram, but instead you could draw a QQ plot against the standard normal distribution. And you're gonna see if that's a straight line, then the stock return follows a normal distribution, which I doubt, right? I don't think it follows a normal distribution. So yeah, that's your work in part C and part D. You look at your histogram and you can look at your QQ plot. You can comment on the p-value that I just mentioned. Um, yeah, so basically I think that's the next homework.